All right, this is part 3 of 3 for the Module 5 student problems. There's only one problem left, so this will be a short video. The problem says thyroxine, an important hormone that controls the rate of metabolism in the body, can be isolated from the thyroid gland. If 0.455 grams of thyroxine is dissolved in 10 grams of benzene, the freezing point of the solution is 5.144 degrees C. Pure benzene freezes at 5.444 degrees C and has a value for the molal freezing point depression constant of 5.12 degrees C per molal. What's the molar mass of thyroxine? Well, on the surface, this seems difficult, but again, it's not really. Because if we look at our freezing point depression equation, delta TF is Kf times M molal of the solute times I, the Van 't Hoff factor. We know I is 1, so we kind of ignore it. We can easily calculate delta TF, right? That's going to be the difference in the two freezing points. So 5.444 minus 5.144, that's 0.3 degrees. Now all we need to do is solve for the molality, and we know that molality is going to be moles of solute divided by kilograms of solvent. And moles of solute is going to be grams divided by the molar mass. We have everything we need to solve this problem, so let's solve it. Molality is going to be delta T divided by the Kf. Again, the I factor is just 1 for a problem like this because it's not ionic. So I get the difference in the delta T's, or the difference in the T's giving me the delta T, divided by my Kf, 5.12, and that's 0.0586 molal. Now, what does that consist of? Well, it's 0.455 grams of the hormone divided by its molar mass. mm's the thing we don't know, the thing we're looking for. And then we divide that by the number of kilograms of solvent, which would be 10 grams. I have to divide that by 1,000 to convert that into kilograms. And then we just solve for mm. Once we work our way through a little bit of algebra, we get mm is 776.5 grams per mole, and our answer is choice B. This is a fairly involved problem, but it's not any more difficult because we just take the equation that we've got, we write out all of the component parts, and we find that we really only have one unknown. Everything else we know. So we put it all in and we solve for our unknown, and it's straightforward. Once we get all that plugged in, it's not even complicated algebra. It's just, it's 9th grade algebra at that point. So I hope this is useful for you to see how these freezing point depression problems can be determined.